Measures of central tendency. We have visited this table before in the previous session, and as we move into the topic of measures of central tendency, let's revisit this table as we use this as a guiding post in learning about the descriptive statistics. So we talked about different types of variables as they are listed in the first column: nominal, ordinal, interval, and ratio. And we talked about individual scores. What do we do to organize them? We hang the numbers, similar numbers together. And that's what a frequency distribution, and we talked about calculating for a percentile within that topic. And now that we know how numbers hang together, what the frequencies look like, we are interested in knowing what the average is or midpoint is. And so that takes us to this topic of measures of central tendency. Under the topic of measures of central tendency, we're looking at three different types of averages: mode, median, and mean. And depending on the type of variables we provide different ways of measuring the central tendency. So measures of central tendency is a fancy word for average, and average is defined by any of these three different ways that we measure. And then in the next sessions, we will talk about how scores vary from one another and how variables correlate with one another. But first, let's talk about the three averages. So we talked about variables as a measurable factor that has an effect on a phenomenon or a phenomena. So anything that's measurable that has categories. And these variables fall into one of two types of variables, and that is categorical or continuous. Categorical variables are variables that have categories that use words, and continuous or numerical data measure variables using numbers. So more specifically then, under categorical data, we're talking about nominal or ordinal types of data, and ordinal takes on an added feature of order or rank built into the categories. Then we have the continuous type that are more specifically interval or ratio. So let's really go through these variables then to kind of recap what types of variables we're talking about. And again, understanding the various types of variables is very important, as you saw in the previous slide with the table, that once we know the type, then we know what kind of central tendency to report. Let's look at these variables. Scores, 0 to 100. What type of variable would this be? Nominal, ordinal, interval, or ratio? But before we ask that question, let's see if we can decide if a variable is categorical or continuous, and then we can go into the more specifics. So would score 0 to 100 be categorical data or continuous data? It would be continuous because it's numerical. Then more specifically, continuous data is either interval or ratio. Which one would that be? The difference between interval and ratio is the non-arbitrary zero characteristic, right? Ratio variable has a non-arbitrary zero that means the same thing to everybody. So if these scores range from 0 to 100 and 0 meant 0% or 0 correct, that means the same thing to everybody. So we would say then it's continuous data and it is ratio. How about favorite colors? Would this variable be categorical or continuous? Categorical, right? And more specifically, nominal or ordinal? Nominal, right? Because we're looking at different categories that are colors. So these categories of colors have no rank or order. So it's a very easy or least complex type of data, which is nominal data. How about age? Is that categorical or continuous? Continuous, because age range from 0 to 100 or 120, or how far out you want to take that. And more specifically, is it interval data or ratio data? It would be ratio data because age begins at 0, and 0 means the same thing to everybody, the point of beginning, right, of a life. Age would be ratio, with the age beginning with 0 to 100 or 120, or how far out you want to take it, with the starting point of 0. And gender would be nominal because it's categorical, and nominal because it has just categories. How about income? Categorical or continuous? It's numbers, right? So it's going to be continuous, and more specifically, interval or ratio. It would be ratio, because if you say you make a certain amount of money per hour, that carries its meaning based on a $0 scale. But you might also argue that if you are talking about a population of those that are working and there's no one that's receiving $0, then you might argue that it's interval data. In its unaltered general form, it would be ratio. How about grades? Let's think about grades as A through F, the letter grade that a student gets in a classroom. So that would be categorical instead of continuous. And would that be nominal or ordinal? A through F has some kind of rank built into it. So we would say that it's categorical and ordinal data. How about types of cars? Categorical or continuous? Categorical. More specifically, nominal or ordinal? Types of cars is just types of cars. There's no order built into it unless you added the rating or the cost, right? So it's just nominal data. How about height? Categorical or continuous? Height is numerical, right? So it's continuous data, and more specifically, interval or ratio. It would be ratio because there is a beginning point on the scale that we use to measure our height, starting with 0. And similarly for weight, this is continuous data, and ratio because it's also a pre-existing scale that we use to measure ourselves. How about pain? You remember the pain scale that we would typically find in a hospital room, say from 0 to 10 as a scale in rating pain score. And so would that be categorical or continuous? It is numerical if we were to think 0 to 10, and so it'd be numerical. And is it interval or ratio? It would be interval because on that pain scale, 0 means different things to different people. Okay, very good. So this helps us to revisit and review the different types of variables. So let's go back to the chunk here of the table that we saw in the very beginning. So I kind of shaded off the individual scores column so we can just look at the types of variables and measures of central tendency together to see which one goes with what. For nominal type, it says to use mode. For ordinal type, it says to use or report median. And then for skewed or ratio or interval ratio, which is skewed data or normal or continuous data together, it says to use median for skewed data and mean for normal data. So let's define what these three central tendencies are. Mode is defined as the most occurring category. So it's the most popular answer if you had a list of answers. Here's a quick example. If you had the scores 2, 3, 7, 7, 8, what would be the mode? The one that occurs the most. That would be 7, because 7 occurs twice. When we think about average, we normally think about the mean, right? And how we calculate for the mean is to add up all the scores and divide it by the number of scores. So if we were to look at the numbers 5, 6, 7, 8, and 9, to find the mean, we would add all the numbers together and divide it by the total number of scores, which in this case would be 5. So added together, all these numbers divided by 5 would give you the mean of 7. Median is typically known as the middle number. So if you see a list of numbers in sequence like this, you would go right to the middle number, and that would become your median. In the case that you have even number of scores where you have to go, let's say there's another number here, and you have to go to the middle, which would be between these two numbers, then you would just take the mean of these two middle numbers. So normal or skewed, let's talk about that. A normal distribution looks something like this, where you have a graph that looks like a bell. And so a normal distribution is also known as a bell curve, where if you were to actually fold these lines to match, one side would be symmetrical or identical to the other side. So a normal distribution has a symmetrical distribution with no skew, with the hump right in the middle of the graph, with the tails that look identical to each other. So any shift from this normal distribution is what we call a skewed distribution. Here are some examples of a skewed distribution. Here on the left side, positive skewed distribution has a graph that has a hump that shifted to the left side, leaving a long tail to the right side or the positive side. So you would see the hump that shifted from the middle, unlike the normal distribution, and the tails look different. There's no tail on the left side, but a long tail to the right or the positive side. Thus, we call this a positive skewed distribution. We want to focus on the tail, and since the tail is on the positive side, we call that a positive skewed distribution. So this would be an extreme case of a skewed distribution. And you have one that looks opposite to this one on the right, called a negative skewed distribution, where you see the hump shifted to the right side, leaving a very short tail on that side, but having a long tail or leaving a long tail to the left or the negative side. And we call this a negative skewed distribution. In extreme skewed distributions like this, if we wanted to see where mode, median, and mean fall, it would look something like this. The mode is where the hump is, because if you imagine a vertical line of frequencies, where the line is at its peak would be your mode, right? Mode is defined as the most popular answer or the most common data, okay? That's where you find the mode. But here's an interesting place for the mean. Now, you recall the mean is to add up all the scores and divide it by the number of scores. So what happens when you have a long line and a positive skewed distribution where you have some really high numbers that create this long tail, since we have to calculate by adding all the numbers and dividing by the number of scores for the mean, we have to calculate all those large numbers into the calculation. What happens then for the mean is that it just becomes much more affected by the large scores, and it shifts further out to the larger numbers, creating an average that may not really represent the entire data. And then you have the median. Now, the definition of median is the middle number, and it's easy to remember on a graph like that. The median falls in the middle, right, between the mode and the mean. So what happens with the median, and the reason why it falls right here and much lower than the mean on this horizontal line, is because in a median, you're looking for the middle number in a sequence of numbers. So from one end to the other end, you're going to go up all the way up just until you reach half point. So it doesn't matter how high these high numbers are, it's not affected by your median. So in a positive skewed distribution, you see that the median is a better average because it represents where the vast majority of the data is. So that's a better median than the mean. In a negative skewed distribution, and here's an expression before we get to the negative distribution. To express then the placement of these three averages, we would say on this horizontal line, the mean is the higher number than the median, and the median is as a higher number than the mode. So the way to know the data and whether it's skewed positively or not is to look at the mean and the median, and if the mean is greater than the median, then we would say the data is positively skewed. In a negative skewed distribution, of course, the mode is where the hump is, similar to that of the positive skewed distribution. And the mean is skewed down because of the low numbers here. And again, therefore not representing the entire data. and the median only calculating from the lowest point halfway up to find the middle number. And the median then is a better average in a negative skewed distribution. So in terms of the placement of numbers, we would say in this horizontal line, the median is a smaller number because it's further closer to 0 than the median, and median is a smaller number than the mode. So anytime you see a mean that is smaller than the median, then we would say that's skewed in the negative direction, opposite to what we talked about here. In the case where the mean, median, and mode are identical, we would say it's a normal distribution. In this case, we would report the mean. So let's add another layer, this drop-down kind of a diagram that we started out thinking about. And the first is to look at the variable. We know that a variable falls into either categorical or numerical. And categorical, more specifically, can be either nominal and ordinal. So when you have nominal and ordinal data measured in words, then we just simply report the mode. On the other hand, when you look at the numerical data that use numbers, and that can be more specifically interval or ratio, rather than trying to figure out whether it's specifically interval or ratio, the critical question is to ask the distribution. What is the distribution? And if the distribution is skewed, then we would report the median. But if either interval and ratio data are normally distributed, it's a normal distribution, then we would report the mean.